How are you, everybody who is watching this fantastic video? I'm very happy to have you, and I would like just to have a little introduction before we start what I've prepared for you today. Firstly, I would like to take this opportunity to thank God who have given me a chance to stand before you in the context or in the work of teaching. Actually, the gift that I'm going to use have been given by God, and it's a gift for me. It's not a talent. Actually, it's not something that we call it just have been given by people, but this is the gift of God. So I thank God that He has given me the gift of being a teacher, and especially that He is teaching modern age teenagers and children. But also I thank God who have given me a gift of being electronics and telecommunication engineer in our beautiful country. My name is Olenjolai. If it's the first time to meet me, I'm very happy to have you today. And I would like to take this opportunity, secondly, to welcome all the online students. But the good news, I have also some physical students who are actually pursuing mechatronics, bachelor in mechatronics engineering at Dar es Salaam Maritime Institute, or DMI in short. That is a very important sea transportation institutions in our beautiful country that's called the Tanzania. That is dealing with sea transport. Also, you have another one which is actually dealing with the road transport, which is road and railway transport, which is called the National Institute of Transport, that's called the NIT. These are very important institutions which are focusing and preparing the mind of the students to keep in focus on solving real-life problems in case of the transportation. But these mechatronics engineers, actually they can work in sea transportation or in other fields related with mechatronics engineering. So I would like to ask you that possibly you met with this video just when you've been searching some videos about electronics online. Then you still have some doubts whether you like to register into our online school or online institution, polytechnics institutions or not. So I want to tell you that it's not important for you to register with something which you are not sure. I ask you to stay connected from the beginnings of this workshop 10 until the end. Then at the end, you can make a decision whether to register yourself or to skip and even using other materials. But I want to tell you that this is the real physical and online school. And we are creating online contents to help students to master the concept. So let me appreciate about the presence of the physical students. How are you, students? How are you, mechatronics engineering students? Yeah. So they are fine. I hope also the online community, you are also fine. So if that's the case, welcome into the modules called the Electronics and Electrical Workshop Practice. This is the very important modules. We train students at DMI in first year of mechatronics engineering. Then we are in workshop 10, so we have done workshop 0 up to 10 because in digital, 0 is powerful number. And the title of workshop 10 is simulating series parallel AC power circuit. So you can see, for instance, that this is the circuit which we discussed, and we did the theoretical analysis in workshop 9. So we discussed this. It means there is a link between workshop 9 and workshop 10. So in workshop 9, what we have done actual, we have drawn this, we've discussed our parallel connection for the AC power circuit. That's a quick review. Say quick review. And then we have just drawn this schematic circuit. And hence I gave students a chance for them to choose the testing points. So we chose point A, from point O, A up to point O. So if you count them, so we have 16 testing points. That is the first business we have done in workshop 9. Then in workshop 9 also we did the theoretical calculation. Say theoretical calculation. Say theoretical calculation. So theoretical calculations on calculating AC root mean square voltage and the AC root mean square current at each point. So we did our calculations in that workshop in case you missed it, but you can access because we have shared it or we'll share it online. So we just did the calculations, the computations to find the measured values from point A up to this point E. No, up to point P. Yes, up to point P. Then I left an assignment for students to calculate the measured parameter point I, then point J, point K, point N, point M, and point L. So how many points? How many points did they leave as assignment? 60 points. Right? So in workshop 9, we discussed about how we can calculate the values the values of current, AC current, alternating root mean square current, and alternating root mean square voltage. Then we had our table. I asked you also to prepare a table of result. Say table of result. In that table of result, we'll have 4 columns. The first column is what? Testing points. We have testing point from point A to point N. The second column is what? Calculated values. Are we together? The third column is what? Measured parameters. And then the first column is what? Simulated what? Values, which we are going to discuss in workshop 10. So in this workshop 10, we have a business of drawing this schematic circuit diagram in one of the offline electronic simulation software, which is called Proteus. But you're not limited to draw these schematic circuit diagrams in other simulation software. You can draw it in Freetism, you can draw it in Maltesium, you can draw it in PCB Artist, you can draw it in Easy Circuit, you can draw it in ACDC, DC visual simulators, and you can draw in different, because I've taught you almost 17 simulation software. So you are not limited, but we just chose Proteus in order to keep a focus of simulating, right? That's the first business. The second business will be drawing our table of result. And when we'll be drawing our table of result, we'll have our table of result, and then we'll be comparing the simulated values and calculated value. Then we can draw a simple conclusions, and we can discuss about relationship between the measured values in simulating or simulated values and the calculated values to see how theory correlate with simulation. Are we together, students? So for the online students, I would like to ask you, in order for you to understand this workshop 10, you must have your computer and the software of Proteus must be installed, and you have to go point to point. So the way that we are going to do this practical is very interesting. It's a practical workshop. Whenever we do anything by using, or whenever I do as your teacher, anything by using my computer, you can stop the video and try it yourself. Then you go to the next sequence, to the next concept, until you build it overall schematic circuit diagram that we have. For the physical students, they have computers already. And for you also online, make sure you have it and follow along, because this stuff are very interesting, however that they are challenging. I think that you have taken your computer, you have a fresh mind, you are ready to put your hands to work. So let us keep on. Are you ready? Yes. Good. During my first year. But remember that in the Word of God, it has been written. There are people who are suffering from what? From the skin disease. All the 10 have been healed, but only one who came back to say, "Thank you, Master, for healing my skin disease." In Swahili we say that, waliponywa watu 10 wenye ukoma. ila mmoja tu ndiye aliyerudi kusema nini? Kwa hiyo mmoja ni 10%. So what I say that will come back, it can be one among 100 students in this class. And I won't be surprised because the scriptures has already said that. Those who used to come back for Thanksgiving, they are always few. Those who say that, okay, even if you didn't teach us, you didn't heal us, we could heal ourselves, we could teach ourselves, it's almost 90%. Are we together? Yes. But remember, there is a power of thanksgiving. When you say thank you, you are opening the gates that give me more. When I give you 1,000, you say thank you, I will add you another 1,000. You say thank you, I will add you another 1,000. You say thank you. So it means that if you say thank you, thank you, thank you, thank you, thank you, you might have 100,000, which can support your life for almost half of the semester. My dear students, at the end of workshop 10, I'm very happy to have you. And I'm very happy to hear that you've understood. And may God bless you. So for those new students, in case that you had a doubt, I told that you stay connected from the beginning to the end. Now you found that our contents can help you to improve your knowledge and skills in electronics engineering. So I ask you now to register into our channel that's called the Online Bachelor Polytechnics of Tanzania, in square bracket Olenjolai. But also we have another polytechnics institution that's called the Online Diploma Polytechnics of Tanzania. So we are providing the contents for diploma students and we are providing the contents for the bachelor students. So it's simple. There's no fare for you to register yourself. Just click the buttons, written, subscribe. Then you have registered yourself and you'll be receiving a notification because we used to publish a video every Wednesday and every Saturday. Okay? So if that's the case, thank you very much. Be blessed. See you in workshop 11. Electronics components. B, we have to pick your T, measuring instruments. Remember that. C, we have also 3. We have C, Roman A, and C, Roman B. C, Roman A, place the electronics components on the drawing window. C, Roman B, it means 3, Roman B, place the measuring instruments on what? So how can we pick the electronics components? We have to go to the Proteus library. So let us click pick. What the first 3 components do we need? A, alternator. Students have already forgotten. Alternator. So here it is. So you have already placed in the object selector window. Then what the components do you need? Single pole, single throw switch. Those are the shortcut. Here it is. We have added an object selector window. Then, we need again what? To pick a resistor of 510 R. Then in category choose resistors. Power rating we choose 0.6. We have already selected. Then we need a resistor. A resistor of 100. So you have a resistor of 100. (0.6 watt). So we have already selected it. Then you have a resistor of what? We have what? Let us pick all the resistors. 1.1 kilo ohm. So just write 1K, 1. So we have it. Next we have what? 470 kilo ohm. Students, are you there? Are we done for resistors? Eh? Then we need what? Lamp. Just write lamp. Lamp. Then choose optoelectronics. We have this lamp. We have placed. What do you still need it? Eh? Class, I'm talking to you. Do you still need any other electronics component? Which one? So we are done. Let us click OK. Then we go for the third step, Roman A. Placing what? Electronics components. So what? Drawing window. The first one, you have to place what? Alternator. Then let us zoom. Then next we need what? Single pole, single throw switch. And next we need two resistors. 510 . And then again we need another resistor, 100. Then we need two lamps. For the online and physical students, you can practice. So here is a lamp. Let us rotate clockwise. Then we can select it. Then we come here for the block copy. Okay? Hey! Then we need what? 1.1 kilo. Then we need a resistor of 470. Then we need the lamp. So for the lamp, we just selected this, block copy. Okay, students? What are we still lacking? Ground terminal. So we have to go to the icon number 8 and let us choose ground. We have placed all the electronics components. Did I forget any? No. Next, we go for Roman E to Roman B. Right? Yes. What are we going to pick? Measuring. Which measuring instruments are we going to pick? AC voltmeter and AC milliammeter. AC ammeter. So where do we get our measuring instruments? In icon number 14. We set it as what? Visual measuring instruments. If this guy has drawn, you don't have a computer. It's a time for you to draw now. And you. This is your work? No. So you have to practice. Or you are making a follow first. Okay. So we need to take our AC voltmeter. Then we need another AC voltmeter at this point. Then we need another AC voltmeter at this point. Then we need another AC voltmeter at this point. 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 Then we need a AC voltmeter for parallel connection. We need a AC voltmeter for parallel connection. How many AC voltmeters do we have there? 1, we have 5, 10, 11. 11. So now we are going to pick what? AC milliammeter. So AC milliammeter, here it is. So let us place it here. So this is still what? AC ammeter. Let us edit property. Change the instrument. Set AC milliammeter. Once we have it, simple. I told you the shortcut. Block copy. We need current where? To measure currents where? Anyway, let's say at this point. We need to measure currents where? At this point. We need to measure currents where? So you still need 2 measuring instruments. Need a AC ammeter at this point. Need a AC ammeter at this point. I think that we have all the 16 measuring instruments. So we are done. We see step number 1, step number 2A, step number 2B, step number 3A, step number 3B. Now we are going for the step number 4. Step number what? Number 3. Step number 3 was what? In step number 3 was also A and B. A, wire all the electronics component. B, wire all the measuring instrument. Simple like that. You don't need to claim. Okay? Do you have any challenge? In case you have any challenge, let me know. So listen, even if you have drawn it before this class, now, if your colleagues who don't have computer, they don't want to use that opportunity to draw themselves, you may take that advantage to redraw it several times. Because maybe after this module, you may stay maybe 2 months or 3 months without drawing. But if you do much practice at this time, you will still remember some of the concept. So I told you the secret to master simulation is actual to do much practice. So you should not be satisfied that I drew it yesterday, or I drew it last week, or I drew it maybe last night. No. You have to do it now. And you have to cooperate. So now let us wire our electronics component. Okay? So let us wire this one. So at this point it means that let us click and then let us wire our alternator. Let us wire our AC milliammeter with the switch. Then let us wire this switch with a resistor of 510 ohm. Then we have already wired it. So listen, when I've been placing the AC milliammeter, I wired it already with what? With a resistor of 40 510. I've already wired it. Right? Yes. Yeah. Please, students, it's not the time to chat. It's time for simulating. It's not the time for slumbering. It's time to make a follow-up. And then we'll practice. Okay. So here we have our lamp. So let us just move a lamp. So then we need the physical connection with this. Here we've wired this. But let us drag a little bit this lamp. Okay, let us wire a resistor of 110 with the switch. So we have our first network. Then next, we need to wire this resistor with resistor of 1.1 kilo ohm. We have to wire it with resistor of 470 ohm. Then we need a wire. You see? Then let us wire resistor of 1.1 kilo ohm with the lamp 3. Let us wire our lamp with AC ammeter, AC milliammeter, because AC milliammeter. Why should we wire the AC milliammeter? Because it is in series. Okay? Yeah. Then let us wire a resistor of 470 kilo ohm with lamp 4. And then let us wire resistance lamp 4 with AC milliammeter what 5, something like that. Are we done? Eh? So are we done with this network? Okay. So now let us connect our circuit, this point of the circuit. Let us connect with what is ground. Okay, then let us connect our ground with what? With the terminal of alternator. Did you finish to wire our electronics components and our AC milliammeter? Eh? Did I do any mistake? Eh? Check please. You are my teachers today. Who has to mark me? Did I do any mistake? No. Thank you. So now we are going to wire the measuring instruments, and we still have only one measuring instrument, which is the AC voltimeter, right? So this is the first AC voltimeter. This is point A, students. That is point A. Will give us the measurement for point A. Then let us wire this terminal of AC voltimeter, this terminal of resistor. That's a wire. This terminal of resistor, that terminal of resistor, with that terminal of 40 of resistor. Then let us drag this one. Then let us connect this AC voltimeter with the lamp. So in case you face a challenge, you can drag the component up or you can reposition it properly. Let us connect this AC voltmeter across R2. And let us connect our lamp. Okay? Okay? Are we done with that part? Then let us connect our AC voltmeter. Cross this resistor. Then let us connect this terminal of AC voltmeter across this resistor. Have you finished? Have you finished to wire all the AC voltmeters? What is going on to your friend there? Kudra. Communicate with your friend, with your neighbor. So now let us connect our, you can rotate this one anti-clockwise. So here it might be a little bit a challenge. Then this is another terminal of AC voltmeter. Okay? Then okay? Is it okay? So we have finished our process of wiring. The next stage, step number 4, rearrange the components. According to your schematic circuit diagram, we have done that. But because now this is the third circuit for you to simulate, you can try to minimize the space taken. Hello? Hello. Morogoro, guy. So I say the first step, you have to rearrange your electronics components in such a way that you minimize. Hey! What are you doing? Last Tuesday, the same process. And Patricia is actually praying for you. Okay. So, the first step, I told you to rearrange. To rearrange what? To rearrange electronics components. So because this is the third circuit, I told you that in order to achieve that process, you have to make sure to rearrange the electronics components in such a way you maximize the use of the space. So that circuit, it has occupied a very large space. So the skill for you to rearrange, you can think, how can I minimize this circuit but without changing any configuration? Are we together? Yes. So I know for the lazy students, they cannot do that. I think that's the point when it is visible. All the parts are visible, isn't it? Eh? Then according to the schematic circuit which has been given, what are the parameters for the alternator? What the amplitude voltage for the alternator? Eh? What the root mean square voltage you have been given? For the AC source, 12 volt. Then what the maximum voltage? In relation with 12 volt, because 12 volts, it's a root mean square voltage. 16.960, 16.2. $16.9, 7, and then what the frequency? 50 hertz. So change. How do you change frequency and amplitude? You just say right click, then edit property, or you double click the alternator. So once we have done everything, then we go for the 50 step. Is it 50 step or 60 step? 60 step. Simulating. Let us run our simulation. What do you see? What do you see? You see different measured electrical parameters, right? So for the alternator, how many voltage do you have there? For the alternator, how many voltage do we have? 12. At point A, we had what an ammeter, isn't it? Theoretically, what was calculated the AC current? 9.8204, right? Milliampere. What the measured value, what the simulated value there? Oh, so what is happening there? Can you show me? You see 0, 0, 0. Every point 0, 0, 0. Then you get confused that, I did everything, then the circuit is not working. Hello? Hello, look on the blackboard. All the 15 measuring instruments read 0. It's just only one AC voltmeter measuring the voltage across alternator reads 12 volt, 0.0, right? Yes. Then you get panic, you panic. But the trick there is very simple. We didn't turn on the switch. But for those who have been praying for the circuit not to work, and then they say, today, sir, today, sir. Today, sir, today, sir. Today, sir, today, sir. It means the circuit is not working before the teacher. So let us turn on our switch. Let us turn on our single pole switch. So now we have the measured values, right? So let us fill our table. So point A, the measured value for the simulated value for point A, the calculated one was 12 volt. The measured one, the simulated one is what? What the simulated value at point A? 12 volt. So Kudra, here you made a mistake, and I know the mistake you did. In the positions of amplitude, you just wrote 12. That's why you have a root mean square voltage of 8.48 volt. Okay, let us continue. Remember that for the case of the AC power, most of the values which will be given in schematic circuit, it's root mean square value. Because I told you, root mean square voltage, it's a working parameter in AC. Okay? So in the amplitude, don't write 12. If you write 12, the AC voltmeter will measure less than 12. Okay? And remember that if you do a mistake in correcting or in just editing the alternator, you'll do the mistake for all the other measured values. That was the trick for that circuit. Are we together? If you wanted to trust what I'm saying, let me show you the secret, because I know that you don't like this stuff. Let me stop the simulation. You just like, but you don't want to pay a cost for it. Would you like to pay the cost for it? Ask your neighbor, would you like? So then, let us write 12 volt. And then for us to have a clear view, let us turn off the switch and let us run the simulation to see the alternator first. What the root mean square voltage that measured by AC voltmeter at point A? Eh? What do you read there? What does AC voltmeter at point A read? 8 point what? 8.4? 8 what? Mangoes. Volt. 8.4, 8 what? Volt. 8.4, 8 what? So, when you have the root mean square voltage of, hey, students, stop writing and stop drawing. Listen and watch. Because I know most of you who have done it, you did that mistake. Why? Because you don't know that the working parameter in AC, especially for the high power, is root mean square value. It's not the maximum value. Okay? So once you have done a mistake there, it means in alternator we don't have 12 volt. We have some other voltage. So that 8.48 volt will affect the measured values, the simulated values. Are we together? Yes. And then we'll confirm that simulation does not relate with what? With calculated values. But the problem is it's what? You. Are we together? So let us turn on, because remember that practicals help us to do mistakes and correct mistakes. Okay. So let us turn on the switch and see the measured parameters. You see the measured parameters are completely different from the measured parameters which we expected. Are we together? Yes. Are we together? Yes. For instance, read the current at point B. Read the current, the measured current at point B. I think it is 60.94 milliampere. Eh? Eh? While the calculated one is 9.8204 milliampere. You have actual a very huge deviation. Are we together? Yes. Because the paper I have there, all the measured simulated values have been found from that circuit. But for me as your teacher, I am happy because you did the mistake, so you can learn from the mistakes. Okay? Yes. If you didn't have calculated values, you could simulate your circuit in that situation, and then you could not notice if there's the mistake. This is the goodness and this is the advantage of calculated value. You know what you expected to measure. So you can challenge what happened. Are we together? Yes. Are we together? Yes. So there we made a mistake. We made what? We made a mistake. And we like mistakes, and we like to learn from the mistakes. Misten is a great school in engineering. So let us correct our mistake. Are you ready to correct the mistake? Let us store simulation. Let us add properties. And then let us fill what? 16.9. No, what? 16.9, eh? Class, 16 point what? Down between? 97. So let us open the switch. That's what I told you. Your troubleshooting should always start from the power supply. So what the power supply? Hello. So what the power supply we have there? 12 volt. So we don't have any problems with the source of power. In case we don't have the correct measured values, that is, might be caused by another reason, but not the source of power. So let us turn on our switch. So we have turned on our switch. What are the measured values? So you see that now the simulated values are closely related with your theoretical value. Are we together? Hello. Hey, there's another class that's going on. What the simulated values at point B? So fill the table. What the measured value at point B? What the measured AC current, alternating currents at point B? What the simulated value? What the calculated value and simulated value? The calculated value was what? 9.82 milliamperes, isn't it? Yes. Then simulated value is what? 9.3. 9.3. 81 milliampere. Note it. And fill it on your table. Then what the measured AC voltage at point C? Calculated it was 0.9438 or 0.94 volt. Simulated it's what? 0.94. Right? Then at point D we have to measure AC voltage. Calculated it was 0.7969 or simply 0.79 volt. What they measured? Class. What the measured value at point D? 0.8, which is closely nearby is 0.79 volt. Then point E, we have to measure AC voltage. Calculated one was 0.0444 volt. Measured 0.04. You see the relationship, eh? Then we go for the point F. We have to measure AC voltage. Calculated was 0.1913 milliampere. What volt? Measured, simulated 0.19. What? Mangoes? Volt. Then we go for the point G. We have to measure what? AC current. The calculated one is 1.85 milliampere. The simulated value? Mangoes. 1.85 milliampere. Then we have what? Point H. We have to measure AC current. They calculated it is 7.9694 volt. Approximately, it's 7.967 milliampere. Sorry, I said volt, but it's milliampere. And what the simulated value at point H? 7.0. Speak it loudly. 7.0. 7.9 milliampere. So 7.96 milliampere, right? Then what is, we have, they measure the parameter at point I. It's AC voltage. They calculated it was 0.235 volt. Approximately 0.24 volt. What they simulated the value? Pardon? 0.234 volt. Then calculated the AC voltage at 20J. It is 10.776 volt. Approximately it is 10.78 volt. What they simulated the value? 10.8 volt. Then they measured the value at 20K. It is AC current. They calculated the value was 9.797, which approximately it is 9.8 milliampere. They simulated the value? Look on the blackboard. 9.79. What he mangoes? You don't mention the unit. Milliampere. Say milliampere. Then at 20 L, we have the measured parameter, it is AC voltage. Calculated is 5.623 exponent negative 4 volt. What did they measure the one? 0.00. So it means that for that one, you have to change it into AC millivoltmeter, because from the calculated value exponent negative 4, it is 0.0.0.056 volt. So it's a very small value for the AC voltmeter to measure. So you have to switch from AC voltmeter into AC what? Milli. Simple like that. Should not have a battle. Oh, that is 0. 0? Who told you 0? Are we together? I taught you how to figure it out. Then at 20 M, we have a measured value, which is AC voltage. They calculated the value, it is 11.0112 volt. Approximately is 11.01 volt. Right? They measured the simulated value. 11. Say 11 volt. Then at 20 N, we have to measure AC current. The calculated value is 2.343 exponent negative 5 milliampere. Which also you have to change the measuring device into what? AC microammeter. Because I think for that one, it reads what is 0. It isn't. So, because you know the calculated value, it can train you about the choice of the excellent measuring instruments. Are we together? Yes. Then here we are. We are in point O. Say point O. Say point O. I love point O because it's the first letter of my name. So we are measuring point Olenjolai. At point O, we have to measure AC voltage. Calculated value, it is what is 0.9882. Simply, it is 0.99 volt. What the simulated value? 0.99 volt. Then at 20P, we have to measure AC voltage. The calculated value, it is 11.0118. The simulated value is what? 11.0 volt. So those are the simulated and calculated values at all the 16 points. If you build that circuit in hardware, also you can do the same measurements at 16 points. And I told you engineering is all about numbers. Engineering is all about what? Formula, the one we used in calculations. Engineering is all about what? Diagrams, like this, that one, the schematic circuit diagram. Engineering is all about what? Tables of result, like the one that we have prepared. And engineering is all about graphs. We did not discuss about graph. We'll discuss about graph later on in other workshop. Are we together, students? Yes. So now you can draw your table of result which contain the calculated values and the simulated values. Students, did you understand? Yes. If you have understood, that is good news. So how can we draw the conclusion? What the relationship between calculated values and simulated values? Is there any relationship? Yes. What relationship? It means that the table results above show that the calculated values are approximately or are precisely equal to what? Calculated values. So if that's the fact, it means that the simulation software performs its responsibility of trying to prove the theory for you. Are we together? Is it clear? Is it clear? So that will be table 2 because we had the table number 1. That will be table 2. Table 2. So if that's the case, I think you have learnt a lot. You have understood. You have got something. You have been improving yourself. You have to make sure you watch this video several times. You draw and redraw. Draw and redraw. Day after day. And then after 4 years of your studies, you will contact me. And I know by that time she'll come to say, thank you for the foundation that you've built.
Africa.